You're not gonna show them?
Yeah, it's all about you. You're the man. Thank you, by the way, for meeting with us.
Thank you for that.
Let's see. I'm just gonna. Oh, there it is. I forget. This is one of those.
I'm not gonna look into the camera. I'm gonna look into it.
Exactly. Yeah. Just look at
you guys.
any of us. Don't worry about it. It's gonna be great. So I was just hoping we could start off. Could you tell us when we ask questions, if you can include the question in the answer, that'll help for the video. And if you could just start off just by introducing yourself and just a very small kind of like what happened in your life that led you into neuro-linguistic programming.
Oh, wait, is that what we're supposed to talk about?
Natural language.
That's very
Natural language processing. Sorry, not neuro-linguistic programming. They get mixed up.
That's a great start because NLP, I think, means neuro-linguistic programming to a lot of people.
Right.
Yeah.
It's a common usage.
Yeah, and a lot of times, suppose that I go somewhere to give a talk, and when academics go to places to give talks, they ask you for an abstract and title, right? So you have to be careful not to use the NLP in the abstract because sometimes the editor is going to be overly zealous and expand that to neuro-linguistic programming. Yeah, but it's natural language processing. Yeah.
Are the two fields related in any way?
I don't think so.
Yeah.
I'm sure. I mean, I actually believe everything's related. So in that way, yeah, things are related. But anyway, hi, I'm Ken. I like languages. I've been interested in different languages for a long time. I pay a lot of attention to communication. I guess when I was in college, so for my native language is Mandarin Chinese. I spoke English, and I learned some American Sign Language when I was in college, and that was a lot of fun. And so things like that just made me interested in language and how it's structured. So I took a couple of linguistics classes when I was in college. I was also interested in math. I was a math major in college. In computer science, I like to program a lot. So when I was about to graduate from college, I kind of started looking at different options. Do I want to go to grad school? What other kind of things do I want to do? So I decided to look for a graduate program in computational linguistics, which includes natural language processing. I should say that natural language processing is kind of an application of computational linguistics, or if you think of natural language processing as the engineering side of what can we build that actually helps people, then computational linguistics is the use of computer science or computation to study linguistics, study how language works, study how it is that people manage to speak and listen, how is it that kids so quickly learn the language that surrounds them. I studied natural language processing and computational linguistics in my PhD program. I also study programming language semantics, it turns out. So nowadays when people ask me what I do, I say I study semantics, which is whatever means stuff. Okay, so meaning, in both programs and natural language expressions can mean things, and I actually find that you can share a lot of tools between programming language research and natural language research. So I spent a lot of time transferring tools from one side to the other, to tell programming language people, hey, there's these cool tools that natural language semanticists have invented that you might want to take a look at, and vice versa. Tell linguists, hey, computer scientists have come up with these ways to write programs, but you can use the same ways to write your semantic theories for natural language. So sort of transferring tools between sort of back and forth. Yeah.
Okay, so you're saying that computer programming languages and spoken languages aren't as alien to each other as we think they are?
Well, I don't think I think they're very different, but when we study them, it turns out we can use the same tools. Yeah, it's like saying that you have a microscope, you could use it to study cells, or you could use it to study, I don't know, ink. Right. I'm not saying that cells and ink are the same thing, but hey, there's the same tool like microscopes or scales, whatever that can be used to study. And similarly, it turns out that logic, for example, and probabilities, these tools are useful both for studying natural language and for studying programming languages. Because of those are two different fields. There are different people who study them. So sometimes people in one field will invent a tool that they didn't know would be useful to other people. So I'm kind of transferring the tool, saying, hey, they've got this tool, we could use the tool.
Okay.
I do that a lot.
Cool.
Yeah.
Do you want
to? So one question, I'm really interested in languages as well. So I guess my first question would be natural language processing for English and European languages. They all derive from Latin, being that they can use the same methods for processing language. So in your opinion, what is the most difficult language that is used within natural language processing? And
I see.
What are your reasons behind?
I see. Okay, so David asked, David, right? Yes, yeah. David asked for natural language processing, besides English, or including English, what's the most difficult language for natural language processing?
What does it follow, like the conventional, I guess, methods of analyzing
language?
So
today, I would say that the more data you have, for example, the more text you have on the internet written in that language, the easier it is to do natural language processing. So English is all over the web. It's very easy for someone to download, not just Wikipedia, but all, like, I don't know how much, you can find statistics, like, there's a lot of English on the web. There's a lot of Chinese on the web, which is not derived from Latin. There's a lot of French, whatever, German. So these become easier because nowadays natural language processing is a lot based on data, a lot based on just looking at patterns that exist in what people currently write. If you are looking at languages that are endangered, maybe there's only 2 speakers left and they don't use the internet, right? How do you get enough data to do natural language processing, to do machine translation, or to even have a dictionary, for those languages? That becomes more difficult. So if you just find one of those dying languages that there are only 1 or 2 speakers left of, okay, those will be the most difficult languages.
Okay. And just to tag along with that, because I'm actually interested in dying languages.
All right. Well, those are the most difficult. If there's 0 speakers, yeah.
Yeah. So like, I guess one question that I really had was, so languages can grow and develop, some decay and some disappear.
Yeah.
So a good example of a dying language is the Norman language in Normandy. It's in France.
Okay.
And
you told me that. I don't know that.
So I think there is around like 1,000 speakers left.
Okay.
And so like for languages like these, how does like the natural language processing program like keep up to date with extinct or dying
Not
languages?
very well today, actually.
And how is like is there like a conservation process or ways that people are going above and beyond to, I guess, preserve the languages?
Okay, so in terms of how natural language processing technologies keep up with dying languages or try to conserve langues,
like store them in like an online dictionary, or like is there any method that people within this field use to, I guess, conserve them?
So I would say that the vast majority of people who study natural language processing, frankly, they may not care that much because they're trying to build products, and it's just very difficult to build products that don't rely on data. But there are people who study natural language processing who ask the question. Some people that are at IU who ask the question, how can we have tools for preserving languages or for documenting languages that not many people speak. Okay, this is actually something that linguists, not just computational linguists, care a lot about. So you have linguists who go all over the world, who try to document languages, who talk in person to speakers of that language. Who actually just ask, learn the language themselves maybe, or ask them, how do you say this, how do you say that, how would you, react in this situation, is it okay if I say this sentence, oh, that's not quite right, what's weird about it, can you correct my error? So that's linguistics, actually, and people call that field work, right? So you go into the field and you work with people who speak that language. And natural language processing can be useful for field work like that, but it's not the focus of natural language processing. So for languages with very few speakers, you end up, if there's some existing corpus, for example, like maybe there's like for some endangered languages there are collections of folk tales that used to be told in that language and not so much anymore, and so you could definitely go through that and analyze that to come up with questions that someone who's doing field work could ask. Okay, and in general, there's for a lot of these data-driven approaches to natural language processing, when data is sparse, when you don't have that much data, often you develop ways to focus new questions. Like instead of just going to the web and downloading all this text and figuring out patterns in how people write English, you might focus on a particular construction, for example, that you're not quite sure about, and the computer might be able to say, there's all that data, that's great, that's useful, thank you very much, but I really have a question about this particular construction. So there's a field, I think it's called active learning. The idea is, in machine learning, how can the machine not just passively receive data and learn from it, but actively ask questions saying, what about this case? Is this case grammatical or not? Or how about this verb? How would you conjugate this verb? Instead of just watching people, they actually goes out and ask questions. And that might be a question that we can pass on to one of the few remaining speakers of the language, so they can more effectively spend their time helping us understand the language.
Oh,
yeah. So that's one thing that natural language processing does. Yeah. I mean, this is very related to, in general, what machine learning does, because that's, again, a field that studies how do you take data, again, not just text, but speech, or the way people move, take all that data and learn patterns from it.
Yeah. Are you familiar with the Norvig and Chomsky kind of debate?
So the question is, am I aware of the Norvig and Chomsky debate? I think I know what you're talking about.
Yeah,
you're getting me worked up as you speak.
So yeah, I guess Chomsky was saying that it's more about systems of rules and structures and nuances, whereas Norvig was saying it was more that probability and statistics is a better way to go. And that seems to be kind of like two camps on the natural language processing theories. Where do you fall on that?
Okay. So about the Norvig-Chomsky debate, is this still going on? I feel like it's a couple years ago, maybe.
It was, and it's not really settled. So
no, it's not settled. I think So there are different things I can say about Norvig and Chomsky. Let's see. Wow, my blood pressure is really rising here. I don't know if I have blood pressure here. So let's see. So I think it's fair to say there are camps, and there are camps who think of themselves as on the rules and logic side, and there are camps who say they're on the sort of statistics and probability side. If you read what Chomsky wrote and read what Norvig wrote, I personally find it difficult to believe that they are discussing or communicating with each other in good faith all the time. There's a lot of rhetoric where it's on both sides, I will say, where it's it's hard to tell between mere ignorance and incompetence and a willful misrepresentation of positions.
Okay.
So I can't tell, and I don't know which one is a more depressing way to think about it.
Okay.
Right? But so that's unfortunate, and I could dig through these writings and just talk about, here they made a point, one of them made a point, and that's just incoherent, it doesn't follow from that, how could, read your, I remember, with both Norvig and Chomsky, sometimes I read them and I want to say, have you read the textbooks that you have written yourselves? and just, you can basically quote their own textbook back at them, and, so that's unfortunate. Another unfortunate thing, which has nothing to do with them, the two of them personally, is just there's actually a perception, very popular perception, not just with the two of them, that there's a choice to be made between logic and statistics. And sort of the fighting type of rhetoric doesn't help. So here's where I stand. It's much easier for me to talk to people who are actually present. So Chung-chieh's not here, Norberg's not here, so I can just talk to you guys. And so here's what's going on. You need both of them. In fact, they really should be combined. We need some logic that can deal with uncertainty. That's one way to put it. And we need some statistics that can deal with structure. Okay, so people often the people who quote unquote fall on the logic camp often ignore how much logic is about patterns and learning what's likely from experience, like how much sort of the not mathematical induction, but sort of induction helps developing logical theories. But on the other hand, people who focus on statistics and probabilities and I would say sort of modern machine learning sometimes overlook how much the insight from traditional linguists, I would say, has informed even just the making of these machine learning methods. Like people nowadays would go through a big corpus like the web or Wikipedia and say, we can look at the meaning, we can get at the meaning of words by looking at what words surround them, and that's pure data. It doesn't involve any logic, any linguistics at all. You just look at which words occur near which other words. But even just when you look at words that are near other words, that's using insight from linguistics. Linguistics tells us that words near each other, first of all, linguistics tells us there's such things as words. Okay. Okay. It talks about morphology. Like a lot of times when you look at a word, you remove the inflections on the verb or on the nouns to get at the root of the word. Right. That's linguistics right there. Okay. How do you do that? And how do you know what makes one word or two? Is ice cream one word or two? Right. And then linguistics also talks about how words near each other are related, like they might be more tightly correlated in meaning in some way. So this also insights that we take so much for granted that we forget where they came from. So I try to recognize the contributions historically from quote unquote both sides, and the challenge, which is difficult, and that's why it's unfortunate that not so many people work on it, because they think there's a choice to be made, is to combine the insights from the two. Yeah.
So basically, you think that the dividing into camps isn't helping the progress?
Yeah, it's not helping. Yeah. I mean, unless people like a spectacle, right? Like I imagine that popular science magazines have written articles that are interesting because everyone likes to watch a fight. Right? So maybe that's helping that way. I don't really think that.
Yeah. Well, it certainly does get some people interested in it for sure.
Yeah. Yes. There's a documentary I think about I forget who, Daniel Everett, who's another one of these controversial linguists who talk about who's engaged in or who was engaged in a fight with Chomsky, and it helps. It makes it interesting.
Yeah, I'll check it out.
I know you said NLP is being used for like machine learning right now and translation, but what do you think in the future, like I guess the most important usage of NLP will be?
What would be the in the future most? Okay, so on one hand, today natural language processing, I would say, uses a lot of machine learning technology. So machine learning is sort of a toolbox, you might say, and natural language processing uses a lot of tools from the toolbox to do things like machine translation. And in the future, what would the most important uses of natural language processing be? Well, it's hard to predict. I guess I'm not sure if what I'm about to say is sort of wishful thinking, saying I hope that people are going to develop this kind of technology. I would focus on connecting people, which is going to involve a lot of understanding at a deeper level what people are saying. Suggesting based on what you read and what you like, what else you might read, who else you might talk to, what else you might like. Being able to cross-reference different people's arguments, being able to go through what Norvig and Chomsky have written and identifying, this part is inconsistent with that part, or this part, it looks like it's disagreeing with that part because of the surrounding invectives, but they're actually agreeing. So identifying places where people have people have hidden agreement as well as hidden disagreements. I guess I would just say that's what I would like to see, and a lot of times people today when they work on these projects, you can kind of interpret that way. That's what they're actually building. Yeah. Yeah. Which, I mean, this certainly reflects a bias on my part. I care a lot about meaning, so I care a lot about what words and other signals mean. Another thing that's important to that is combining language, like words, with other kinds of information, right? So, for example, there's a lot of work nowadays on matching words with pictures, so that when you have like if you have labels for a photo, but you might have the description of a movie, you can match up, a textual plot summary of a movie with parts of the movie, right? And matching it up with people's behavior also. Like if I'm in a certain place and I tend to speak in a certain way, I tend to behave in a certain way, and use that to connect people. Yeah, I guess one concern of that is privacy, and yeah, I'm not sure. There is a line that we have to be careful about.
Okay. I'd just like to tag along. Being from, I came from an international school, so I guess my first time I actually saw natural language processing in use was the first translation between different languages. Translators that were actually made for students like us could use with other international students. And because
so this is when you say international school, you mean a school where the students come from all countries?
Yeah.
So I see. High school?
High school.
Oh, I didn't know that.
So we all had backgrounds from different countries, and English was our second language. So we frequently used translators to.
I'm imagining they give you these handheld things.
No, just basically handphone applications.
Okay.
And it was the first time a translator came out.
Okay. I've never seen people use it like that in a school setting. That's great.
So that's one way that we used it. And I guess that was my first perception. But going along to my question, I guess, do you think there is a limit to natural language processing? Where do you see this coming to an end, if there is?
Is there a limit to natural language processing? Well, it'll be hard to do better than people, actually. So that's my first instinct is to say, well, there's a goal, which is to behave the way people would, right? So if a computer downloads the web or Wikipedia, they should behave like someone would if they had all the time to read all the web, to read all Wikipedia, right? So there's always that kind of goal, that kind of ideal, right? But other than that, I don't know. I mean, I don't personally see a firm line between machines and people. Actually, I like to say, if you want to build an artificial intelligence, just have children. That's like artificial intelligence, right? Most people are intelligent. So it's kind of hard to really say what it means to have a machine rather than a person. Yeah, I don't know. I think I could. I don't see a lot of limits. I don't see any limit besides just it'd be pretty hard to do better than people today do.
Okay, and just along with that, I just told you my first perception to natural language processing. I guess with that, what are some other applications of natural language processing that are trending or have been in use for a while, or some that people don't know a lot about, but it's used a lot.
Huh. Right. So machine translation is kind of a flashy thing that people use. Yeah. I also think a lot of I mean, I don't know if you consider search engines to be like Google or to be an example of natural language processing. More and more it is. Yeah. It used to be that you type a word, it's just looking at web pages that contain that word that are important. So that doesn't involve a lot of natural language processing. It works just as well for English and as well for individual languages. But nowadays, there's a lot of intelligence that suggests queries to you. It will try to decide: are you looking for a recipe? Are you looking to go somewhere? Right? Are you looking for a person to talk to them, or what are the different cases? And that involves understanding in more deeper level, not just the words you type and how this big query, how this is split into words, but also what you want, like your actual intent. Yeah. So I think that's a little bit more hidden.
Okay.
Yeah. But I feel like there's got to be. Let me think about it. Are there sort of more hidden uses of natural language processing?